Number 1, the table below shows the political party registration by gender of a sample of 500 registered voters in Franklin Township. So we have a sample of 500 voters, and we have their gender and their party affiliation. So, what is the probability that a randomly selected registered voter is registered for Party Y? So I'm picking someone at random, so what's the probability of Party Y? Well, how many people in Party Y? 168 out of 500. If you wanted to make that a percent, you could, or a decimal, you could, by dividing in your calculator 168 divided by 500, and I got 0.336, which is 33.6%. Now we have a conditional probability here, given that a randomly selected registered voter is male. So we're given that they're male. What is the probability that he is registered for Y? So what's the probability of Y given that he's male? So I know that he's male, my world shrinks to that male row. I know I'm picking from one of those 200 people. What's the, how many males are in Y? Well, only 48 are. So 48 out of 200. If I make that a decimal or a percent, I divide and get 0.24, which is 24%. So given is the key that we're computing a conditional probability is there. Knowing that the voter was male, how did that affect the probability of picking a voter registered to Y? So the probability of picking a random person and them being affiliated with party Y is 33.6%. Knowing that they're male and then trying to pick someone from Y, that probability went down to 24%. So knowing they were male decreased the probability. Knowing they are male, knowing the voter was male, decreased the probability of picking party Y. So these two events, there seems to be some kind of association between them. Gender and party affiliation appear to have some form of association between them because knowing they were male decreased the probability of picking someone affiliated with party, registered with party Y. Given that a randomly registered voter for per, given that a randomly registered voter is registered for party Y, so I now know they're in party Y. What's the probability that he's male? So I'm finding male given Y. So I now know they're in Y. What's the probability that they're male? So how many people are in party Y? Well, there's 167. So my world has shrunk down to just being in party Y. Before, I knew they were male. So my world shrunk to that row. Here my world is shrinking to that column. How many of them are male? 48. So, what's this probability? 48 out of 168. 48 out of 168 is approximately 0.286, so approximately 28.6%. When in doubt, go out 3 places. It never hurts. Or leave it as a fraction, because that's also correct. So how is the probability different than the second probability that I calculated? How is this probability different than P of Y given male? Well, in this probability, we're given male. I know they're male, my world shrunk to that row. Here, I know they're in party Y. So my world shrunk to everyone who's in Y. I wanted to know how many males could I pick. Versus over here, I knew they were male, so I had only men, and I wanted to know how many of them were in Y. That's the difference. Conditional probability can be confusing if you don't understand what's going on. The given information, this is the given part, tells you what to shrink your universe down to. I'm not picking from the total 500, I'm picking from a row total or a column total.